you're gonna hear a repeat. When we double a quantity, when we're dealing with a double of a quantity, we can either multiply it by 2 or we can add it to itself. Either way is a double quantity. So when we have a double angle down here, we have the sine of 2a, we can rewrite that as the sine of a plus a. Well, that's an angle addition now. So let's look at our formula sheet. We did the sine of a plus b. What would it look like sine of a plus a? Expand out the formula. Expand out the formula. Sine of a plus a. Rather than a plus b. You'll just write sine of a and then cosine of, well, it was b, now I'm just going to have it at a. So just expand that out using your trig identities or your trig formulas. Those trig formulas aren't going to go away. We'll be utilizing, my goal is by the time you eat turkey, we'll be done with trig identities. That's a good thing. Expand out sine of a plus a. We have a plus b. Now we're just adding a plus a. Mason, what do you have?
Sine a times cosine a plus cosine a times sine a.
Okay, just expand it out. I don't have a b's there. Well, if I have 5 times 4, the question is, does this equal 4 times 5? Are those two equal? Yeah. What property is that? Do you remember? Commutative property. Very good. Ooh, good start there. Okay, it's a commutative property. So the sine of a times the cosine of a I can rewrite this as sine a times the cosine of a, because 5 times 4 does equal 4 times 5. Well, if I have xy plus another xy, using my algebraic skill, Braden, what's that equal? Xy plus xy. 2xy. So if I have sine a cosine a plus another sine a cosine a, that's going to give me 2 sine a times the cosine of a. And this is your sine of 2a. Once again, something else to add to your identity sheet. Sine of 2a is 2 sine a times the cosine of a. And we could just refer to a reciprocal function. We have the cosecant of 2a would be 1 over sine of 2a. So it's just a reciprocal function. Okay, let's take the cosine of a, or cosine of 2a, which is the cosine of, once again, we can expand that out, a plus a. So expand out your cosine of a plus a. Cosine of a plus a. Randy Hampshire, what do you come up with?
Cosine of a times cosine of a
Well, if I have cosine A times cosine A, how can we rewrite cosine A times cosine A? Lexi? Cosine squared of A minus sine squared of A. Now with the cosine of the double angle, we got two alternate forms that we can work with. Because what we have here is we have cosine squared and we have sine squared. Which, if you remember back, or look back, we have, let's see, cosine squared of A is equal to 1 minus sine squared of A from previous things on the identity sheet. So if I recopy this, this is equal to, making a substitution, 1 minus sine squared of A minus another sine squared of A. Well, if I have 1 minus x, that gives me 1 minus 2x. So there's an alternate form for the cosine of 2a. Likewise, sine squared as A is equal to 1 minus cosine squared of A. I could substitute in for sine squared also. So we have cosine squared of A minus, now I gotta watch myself here, 1 minus cosine squared of A. Using our distributive property, we have cosine squared of A minus 1 plus cosine squared of A. So this gives me 2 cosine squared of A minus 1. So your double angle for cosine, you have 3 different formulas for that. Cosine of 2a is cosine squared minus sine squared. I typically go to that one right there. But you have, there is uses for the other two that we'll get to when we go into half angles. But for double angles, I typically will use cosine squared minus sine squared. But that's also equal to 1 minus 2 sine squared or 2 cosine squared A minus 1. Once again, a couple more things to add to your double angles. Or to your formula sheet. Expand out tangent of A plus A. You should be able to, with what we just did with these first two ones, you should be able to simplify the formula. Tangent of A plus A. Go to expand it out, see what you can do to simplify it. On top we should have tangent A plus tangent A. On the bottom 1 minus tangent squared A. James, what's tangent A plus tangent A? 2 tangent A. On the bottom we have 1 minus tangent A times tangent A. That would give us what? Tangent squared of A. So there's my tangent of a double angle. And once again, cotangent would just be the flop of that, the flip of it. Alright, the tangent of angle A is 4/3 in quadrant number 3. What's the first thing we think we should do here? Isaac Phillips, what do you think we should do first? Yeah, draw a picture. Let's draw a picture. So in quadrant number 3, I'm going to draw my angle. And the tangent of that angle, here's my angle A, is 4/3. So the tangent of A is 4/3. So opposite is going to be 4, adjacent is going to be 3. Which means our hypotenuse would be what? Coulter? 5. And now I need to check for negatives. Anything going to the left or downwards has to be negatives. Okay, always have to check. So we have negatives for both of them. Sine of 2a, expand it out. How can I rewrite sine of 2a? Which is 2 sine A times the cosine of A. So look at your triangle. What's the sine of A? And what is the cosine of A? Isaac Wenger, what's the sine of A? What's the cosine of A? We're multiplying fractions, so we multiply across the top, we multiply across the bottom. Once again, we're used to these types of problems now. These tend to go a little bit better because we're a little more comfortable in our own skin doing these problems. So I multiply the tops, I multiply the bottoms. Brain, what do you come up with? 24 over 25. Cosine 2a. Now, once again, I typically will go cosine squared of a minus sine squared of a. Reason why is when I do my ratios here, I have to square them. Well, my ratios are adjacent over hypotenuse, my opposite over hypotenuse. My hypotenuse is going to be in both of my denominators, and to be able to subtract two fractions, I need to have a common denominator. Well, this will give me the common denominator. So I find the cosine of A, I find the sine of A, and then I square all my quantities. And once again, it will automatically give you a common denominator, which is nice. When I square negative 3/5, Grace, what did you come up with?
9.
And when I square 4/5, negative 4/5? When I square negative 4/5, 16 over 25. So I have to now subtract these two fractions, so I have 9 minus 16 over 25, or negative 7 over 25. Tangent 2a. Once again, I could use 1 minus sine, 2 sine squared of a, or 2 cosine squared of a minus 1, come up with the same solution. Once again, the nice thing about this, I could do a lot of things mentally here, and I don't have to worry about a common denominator. It's already there for me. Tangent 2a, expand it out. Now with my tangent, I have negative over a negative, that's going to give me a positive, so I can simplify that down before I start doing any calculations. Or I can look at the top, I'm giving you tangent of a is 4 over 3. I would simplify out first, so I have 2 times 4/3, which gives me 8/3 on top. And 1 minus 16 over 9 on the bottom. Once again, you could quantify both of these, hit math, hit enter, and it'll take you back to a fraction. Or you can multiply both top and bottom by the value of 9. You could do either or, whatever you're more comfortable with, that is fine. You can quantify the 8/3 on top. You can quantify the 1 minus 16/9 on the bottom. Okay, and divide them out, hit your math button, hit enter, it will take you back into a fraction. If you want to multiply top and bottom by 9, we had 24 on top, and then 9 minus 16 on the bottom. Or 24 over negative 7, or negative 24/7. Once again, you do what you feel comfortable with. But I would do some mental math here first. I'm multiplying 2 over 1 times 4/3. It gives me 8/3. I'm squaring 4/3, which I'm hoping we can do. Okay, we've been there, done that in our first rodeo going through the squares. I'm going to change this last problem. Let's change it to 2 sine theta cosine theta is equal to 1/2. Just making that a 2. Now I'm looking at the right-hand side. I'm looking at the right-hand side. What looks like 2 sine theta cosine theta and taking it to the left? Which double angle is it? Sydney, what double, Riley, what my bad, oh my goodness sakes. What double angle is that one? My bad. Which double angle is 2 sine theta cosine theta? Look at your list. Left hand side, which one's 2 sine theta cosine theta? Okay, that's sine of, let's see. That is a sine of 2 theta is equal to 1/2. Now we're going into solving a problem. Emma, what are we going to do both sides to get rid of the sine? Inverse sine. So we're going to take the inverse sine. We take the inverse sine. Remember, we get 2 values. Inverse sine, we get 2 values. Get the calculated value, which is the principal value, and a second value. What's our 2 values, Molly?
I have 15.
Before, just inverse sine of 1/2.
Oh, 30.
And,
And then -30. Wait.
no, inverse sine,
Oh, 150.
150 is supplement. Now we divide ourselves by 2. Then we'll get our 15. Plus or minus, here we'll get our theta is equal to 75, plus or minus, what's the period gonna be? 180 N. Because our B value turns into 2. So the period is gonna be 360 divided by 2. Or you can think of it this way also. I take the inverse sine, I get 30 plus or minus 360 n, but I have to divide everything through by 2, so that will give me 180 n. You can think of it that way also. Double angles tend to be a little bit easier than angle additions, just because you're used to the types of problems that you're running into. You're used to applying formulas and applying them to triangles, so they tend to be a little bit easier. Your homework is on page 132, 133, 9 to 30, the multiples of 3. You have about 15 minutes here in class. Use it wisely.